Hello, students. Transformers play a vital role in the power system. People often metaphorically refer to them as a part of the human heart. This scenario primarily focuses on power transformers, covering their structural principles and classification. The application of power transformers in power systems, items to inspect during transformer operation, as well as common faults and handling methods. You will also learn about transformer electrical tests and their qualification requirements. Let's study together the structure and working principle of transformers. The learning objectives for this lesson are: understand the structure and working principle of power transformers, develop the ability to analyze and determine transformer structures, principles, and types. We will emphasize learning transformer working principles to enable future accurate standardized operation, maintenance, and repair of transformers. What exactly does a transformer do? Students, have you learned about the basic structure of transformers actually? After electrical energy is transmitted to consumption areas to meet the power requirements of electrical equipment, it needs to go through various substation levels using transformers to reduce voltage to the values required by various electrical devices. A transformer is a static electrical machine that primarily uses electromagnetic induction principles to convert AC electrical energy of one voltage and current into electrical energy of another voltage and current at the same frequency. In other words, transformers enable the conversion of electrical energy between different levels. These two images show commonly used transformers in power systems as critical infrastructure for urban power transmission and transformation. China has repeatedly issued policies to promote the development of the transformer industry. According to current statistics, China's transformer production volume is relatively high, with export share ranking second globally. Meanwhile, with the successive implementation of UHV projects across China, China's power transformer market will show new phased growth. In 2021, China also introduced a transformer energy efficiency improvement plan. As China's energy conservation and consumption reduction policies deepen, China's transformers will develop towards environmentally friendly, compact, and intelligent designs. Now let's examine the types of transformers currently available in China first. By function, transformers are classified as step-up transformers and step-down transformers. For example, factories or substations typically use step-up transformers, while terminal substations use step-down transformers, also known as distribution transformers. By phase number, they are divided into single phase and three phase. In factories or substations, three-phase transformers are generally used. According to voltage regulation methods, we classify them as off-load tap changers and on-load tap changers, or substations mostly use off-load tap changing transformers. By winding configuration, they are single-winding auto transformer, winding transformers, and triple-winding transformers, Mostrial winding transformers, or substations mostly use double-winding transformers. Based on the insulating medium, we further classify them as dry type and oil-immersed transformers.
Oil-immersed transformers are subdivided into oil-natural-air-natural, ONAN, oil-natural-air-forced, ONAF, and oil-forced-air-forced, OFAF, types. Generally, factories or substations typically use ONAN or ONAF transformers. By the conductor material of the windings, there are copper wound and aluminum wound types. By neutral point insulation level, they are classified as fully insulated and semi-insulated transformers. However, although there are many types of transformers, their basic principles and structures are almost identical. This shows an overall view of a transformer. External structures mainly include a thermometer, oil conservator, also called a breather, Buchholz relay, bushings, which are further divided into high voltage and low voltage bushings, tap changer, tank, and grounding terminal. Internal structures mainly consist of the core and windings. After the transformer's primary winding is connected to an AC power source, the alternating current flowing through the winding produces magnetic flux. Under the influence of this flux, an alternating magnetic flux is established in the core. That is, the primary winding draws electrical energy from the source
and converts it into magnetic energy due to electromagnetic induction. Electromotive forces of the same frequency are induced in both the primary and secondary windings respectively. Under the influence of this induced electromotive force flows through the load. The magnetic energy in the core is converted back into electrical energy. This is the working principle of a transformer using electromagnetic induction to transfer electrical energy from the source to the load. During transformer operation, Attention must also be paid to changes in certain operating parameters. If changes exceed allowable limits, they can cause abnormal operation or faults in the transformer. For example, allowable temperature and temperature rise. Maximum allowable winding temperature is 105 degrees Celsius. The maximum top oil temperature should not exceed 85 degrees Celsius.
Normal operation temperature
Should be around 75 degrees Celsius. Exceeding these maximum temperatures may cause phenomena such as oil gasification. For the applied source voltage, whether for step-up or step-down transformers, voltage should operate within the rated range. However, some variation is allowed. Within a range of ±5% of the rated value, normal overload should be between 40% and 70% of the economic operating load. This means phase currents must not exceed the rated current. The maximum unbalanced current for the transformer must not exceed 25% of the rated current on the low voltage side. The insulation strength of the transformer oil must be within qualified limits. There should be no oil leakage or seepage. Besides monitoring the parameter changes mentioned above for standard transformers, for transformers equipped with special devices, the following should also be noted, such as transformers with explosion vents and transformers with pressure-type temperature gauges. The protective devices of the transformer should meet selectivity requirements. If transformer parameters exceed the allowable range, the transformer will operate abnormally. A humming sound can be heard at this time. Therefore, operators need to possess certain professional qualities and a careful, attentive work attitude to promptly detect abnormal phenomena in transformers, because if abnormalities are not detected timely during operation, it can lead to safety issues or escalate into a transformer accident. Well then, that concludes the content on transformer functions, structure, and principles. Next, please complete the post-lesson review questions. After accurately analyzing the transformer structure and Renly principles, state what the normal operating temperature of a transformer is and what hazards arise from excessively high temperatures. Thank you for watching. Goodbye.